We have a system of equations to solve. The system has two equations and two variables. So what we're trying to do is find the value for x and y that make both of these equations true. So we have several choices to start. The general idea is we want to pick one of these two equations and solve it for either of the two variables. So we really have four choices. We can take this equation, solve it for x, this equation, solve it for y. Or we can take this equation, solve for x, this equation, solve for y. Three of those four choices are going to be better than that last choice. So in general, the easiest thing to do is look for an equation where there's a variable that has a coefficient, so that's the number in front, of either 1 or -1. And we see that that happens here in this first equation for x and the second equation for either x or y. Okay, that's just going to make the algebra a little bit easier. So I'm going to take the first equation. I'm going to copy it, x plus 2y equal -7. And I'm going to solve this equation for x. So that means I need x all by itself, everything else on the other side. So I will subtract off the 2y. Okay, now this tells me that x has to satisfy this relationship no matter what for this system. So I'm going to take this expression and put it in for x in the other equation. Got to make sure you use both equations. So instead of, I'll copy it here, instead of the equation x plus y equals -3, I'm going to substitute, that's what this method is called, -7 minus 2y in for the x. And then I still have plus y equals -3. And now I have an equation that just involves the variable y, so I can solve. So if we simplify the left, -2y plus y is minus y. Okay, I want the variable on one side, numbers on the other. I see that since this is a -y, it's going to save me a little bit of algebra if I add that to the other side of the equation, so that makes it just plain old y. And at the same time, I'm going to add 3 to the other side, and that'll give me a -4. So now I know the value for y is y equal -4. That doesn't solve the system, though. I still have to figure out x. So now is where I'm going to come back to this rearrangement where I'd use the substitution for x to be -7 minus 2y, and I'm just going to use that to evaluate x. So x is -7 minus 2 times, my y value is -4. And now just simplify. -7, let's see, 2 times -4 is -8, and I subtract that, so that's going to become add 8. And that gives me an x value of +1. Now I'm okay with you leaving your answer as y equal -4. Let me write the x down here again. X equals 1, that's fine. If you are using my lab math and it asks you for an ordered pair, that means what you need to do is put as the coordinates of a point. So we would have parentheses, x value is 1, the y value is -4. So I'll block that off as well. Okay, that's another option for you to do, and my lab math might require you to do it this way. And of course, what this means is that if I take these numbers, 1 for x and -4 for y, and I substitute those back into these equations, they should both be true. And you can certainly do that as a check if you want to, but it's not required.